Hey everybody, this is the 1.3 section. This one's kind of a funky section, I'm not gonna lie. Like, we're just talking about types of numbers and the number line, and these are things that honestly we probably talked about in like 7th or 8th grade, and then we never talked about it again. And that's okay, we're just kind of reviewing it right now. I know you don't really want to talk about middle school, I don't really want to talk about middle school, but we're gonna have to go there, and that's okay. So, we got a ton of vocab right here. Okay. The first vocab that we have is natural numbers. Okay. And then I gave you a little example right here. See how it says 1, 2, 3, 4. It's the set of they're called natural numbers. I sometimes call them counting numbers. Like if you are counting on your fingers, you can see those numbers. Okay. Even beyond 10, like 12, 13, 14, 15, like whatever. That kind of thing. Those are the numbers that are your natural numbers. Okay. Whole numbers. Whole numbers right below it. Look, it gives you an example again right here. 0, 1, 2, 3, 4 is the set of whole numbers. Now, it's pretty much the same as natural numbers. Our only difference is this guy right here, right? Like we didn't have 0 in there. We didn't really have, that's the only difference. So the only difference between those two is 0 is included. So that's all you really have to add between those. Okay. So we're slowly building, right? So we did natural, we did whole, now we're on to integers, okay? Integers are pretty much whole numbers, but now you can have positives and negatives, right? See how you've got like two ends? Okay, so maybe right next to it you write plus slash minus. These numbers are found on the number line. Remember how I said we were going to go back to the number line? Yeah, this is what we're talking about. The next two are the ones that everybody has a really, really hard time with. So the rational numbers is, do you see how I have like a little fraction like x over y, or y, x slash y? I don't like that one. I'm going to let you know that right away. Like, I don't like it. It's fine. It's not, we don't really use it a whole lot, to be totally honest. But as long as you can like write something as a fraction and the denominator is not 0, then you're good to go. When the denominator is 0, that's a no. We don't like it. Can't do it, right? The second notation is called set notation, but we don't use it a whole lot. So like don't worry about that really. Alrighty. So irrational numbers. It's non-rational numbers, so it's numbers that like you can't write as a fraction because their decimal is it continues. So it repeats or continues with no pattern. Okay. Most of the time, I don't really like this definition of irrational numbers. Like most of the time your irrational number is a square root. That isn't like a nice square root, and like pi, and that's pretty much it for irrational. And then the real numbers is everything. So everything is a real number. We're not going to talk about imaginary numbers until next semester, so don't worry about things not falling into the real number category because we're not there yet. Okay, so here's the deal. You have some examples on your homework where what you have to do is you're going to have multiple windows in a problem. And it's going to ask you to list different numbers from the set. Now you're going to have one task, it'll push enter, it'll say good job, and then you move on to the next one. So I'm going to kind of walk you through that. So here's our set of numbers, okay? In number 1, we have all these guys. I'm just gonna kind of go through them really quick just because there's one in there that's trying to trick you. So I have -6, I have -2/3, 0.2, square root 3, 4.5. This is the tricky one, square root 49, okay? Can you take the square root of 49? Yes, you can. It is 7. Why am I pointing that out? Because you have to think of this as 7, but when you answer like which one it belongs in, you have to list it as square root 49. So part A, the very first part, asks you for the natural numbers. Remember, the natural numbers are the ones you can count on your fingers, okay? So no negatives yet, so we're going to ignore these guys. No negatives, no 0 yet. None of these are a whole number. This guy is, though. Even though it looks weird, we are going to list it because we know that the square root of 49 is just 7, okay? You also have to put these curly brackets when you do your answer, so make sure you have that as well. So you put that in, push enter, and it say, good job. Then you go on to whole numbers. Okay. Above where our vocab was, remember we said that whole numbers was pretty much the same thing as the natural ones. We just need to add 0. So I see 0, so 0 is part of this, so I am going to put 0. And I am going to also put square root 49. Okay, because remember these first ones kind of build on each other. So like if something's a whole number, or a natural number, it's also a whole number kind of thing. Integers. So now we're talking about numbers that are like whole, but they also can be positive or negative. So now we're allowed to include this 6 or the -6, because now it's on the number line, right? So I'm going to put -6. 0 is still an integer, right? Everything from my whole number section. And square root 49 is still an integer. Push enter, it would say good job. This is the confusing one. So with your rational numbers, you want all the fractions and all the nice decimals, like the ones that like end, okay? You can also use anything from up here is automatically going to go into there, okay? So if you want to start with that, do that, okay? Start with -6, 0, and square root 49 because I already listed those. Now I'm going to go back up to my set and I'm going to go, okay, what's a nice fraction, a nice decimal? -2/3 is a nice fraction, so I'm going to put that one. 0.2 is a nice one, and 4.5 is a nice one, so I'm also going to put that. So 0.2 and 4.5. Okay, notice how I didn't put this square root 3, because square root 3, if you put that in the calculator, it's a nasty decimal. It's just like, it goes on and on and on and on and on forever and ever and ever and ever. So we don't really like that one. Okay, cool. So anything that is not a rational number is an irrational number. So I pretty much listed everything right here. The only thing I didn't list was that square root 3 that I just talked about. So that's going to go in the irrational set, and it's going to be the only thing in the irrational set. And then remember, we talked about how real numbers was everything. So what you can do when you get to the real numbers is just copy that whole set of numbers. So -6, -2/3, 0, 0.2, square root 3, 4.5, and square root 49. This is like the easiest question, the easiest part of these ones on like a test or a quiz or whatever. Like, you can at least answer real numbers because it's going to be the list of all of them. And I tell you that before a test, so you should definitely get that one right on your homework for sure. Okay, number 2, tell whether each statement is true or false. Okay, so this is a 2-part question, so we're just going to see part A first on our screen. So a number can be both natural and negative. So our natural numbers, let's talk about, remember, those are the ones that I can count on my fingers. So 1, 2, 3, 4, 5. Can't really count negatives. So that's going to be a false. So you'd push false, you'd push enter, it would say good job. It would give you a new one, which is part B. Every rational number is an integer. Okay, well, let's look at our example. Let's find the rationals. This is the integer list. This is the rational list. Is every single rational number in the integer list? No. Okay, and this says every. It doesn't say some, it says every. So that would be a false because not every single one works for that one. Alrighty. Okay, we got a couple of ones like these. It wants you to just talk about like what the number would look like in bold if I just wrote it as one number. So part A says the lowest Fahrenheit temperature ever recorded was 129 degrees below zero at Vostok, Antarctica on July 21st, 1983. So let's see. If I want to put 129 below zero just as an integer, remember an integer can be positive or negative. Below zero, that is a negative, right? It's under zero. So I would put negative 129 to represent that number. And then same thing on part B. General Motors had a loss. Okay, so loss, that's telling me it's probably minus 31 billion in 2008. So I'm going to put minus. I'm not going to put minus 31 because that's saying like just 31. I'm going to make sure I label that as 31 billion. So then I know how much. Okay. Cool. So the next one would like you to graph the numbers on a number line. So this, when you do this problem on MyMathLab, this is how it's going to look. You're going to have something that looks like this with a bunch of lines on it. Okay, it might be labeled like by ones. So I'm going to put, I don't know, negative 6, 4, 2, 0, 2, right? And I want you to put the dots on there. There is going to be a dot tool. Okay, so all you have to do is click the dot, drag it to where you want. And we're going to do all of these. So I'm going to do negative 2 in green. So all I'm going to do is I'm going to take the dot, I'm going to click on negative 2 on MyMathLab, which is right here. Put the dot there. Okay, and I'm going to call it good. I'm going to label them if they're not actually on a number, and this one is actually on a number. It's on negative 2, so I'm not going to worry about labeling it. I'm going to do negative 6 next. Here's negative 6 on the number line, so that's where I would put my dot. Okay, I made it in pink, so that one is good. I'm going to extend my number line a little bit because I see, I see that I have 4. There, problem solved. Okay, my next number that I'm going to put on is 4. Okay, I'm going to put 4 on in orange, right there, right, pretty easy. And then the last one I have is 1.5. Okay, on MyMathLab, if you kind of drag your cursor across this, it tells you like, yeah, you're at 1.5, like right here. And then it should label it for you, but I'm going to write that right there just so you guys can see that this little light green one is 1.5. And then once you've plot all your dots, you would just push enter and it would say good job and you're done with that one. The last thing that we're going to do today is we're going to do a bunch of problems that kind of have to do with absolute value. Okay, absolute value is the distance between a number and 0 on the number line. Okay, so when we think of absolute value, we're thinking about like, okay, how far away from the 0 is it? Okay, distance, when I'm talking about how far away something is, it's always positive. It does not matter what direction you're moving in, right? Like if I say I am 5 feet away from the door, okay, it would not make sense if I said the door is negative 5 feet away from me. That's weird. We don't do that, okay? I just sounded stupid. So you always need to put a positive number when you're talking about absolute value. Always, always, always. So when we take the absolute value of a number, we should always get a positive. Okay. There is only one exception, and the only exception is when the negative sign is outside those absolute value signs. The reason why is when it's outside, it's like a coefficient. Okay, so we kind of treat it like times -1. All right, so absolute value bars look like these guys. Okay, they're just straight bars up and down. It's saying how far away is this number from 0. So my number is -5. -5 is 5 spots away from 0, so I would put 5, right? A positive answer. Put that in, push enter, and it would say, good job. Number two, I have that negative on the outside. Here's what I do when I do these problems. When I see the negative on the outside, I just write it, so then I don't forget. Okay, because then whatever I get for my absolute value, I know it's going to be negative. So inside my absolute value bars, I have 54. So I'm doing the absolute value of 54. 54 is 54 spots away. I put that negative on the outside. I am good to go on that one. One more. This one's kind of tricky. Okay, so I do have a negative on the outside. So let's go ahead, bring the negative down, put it on the outside so I don't forget it. Now inside I have -5/7. How far away is -5/7 from 0? It's still 5/7 spots away. Even though I know I have negative, this time it doesn't make a positive. The absolute value bars are like blockers, okay? It's blocking you from distributing that. All right, so just a reminder, if you're using the number line, remember that the big numbers are on the right, so go to the right for the big numbers and to the left for small numbers, right? Less is left, okay? All the small ones are to the left. It wants you to select the smaller of the two numbers. Okay, so what I would do is I would look at, let's see, I have absolute value of -3 and I have 1. Okay, absolute value of -3. Let's do that first. So how far away is -3 from 0? It is 3 spots. So really I'm comparing 3 and 1. Okay, so which one is smaller? If this one's easy now, it is 1. So I would put 1 in for my answer on my math lab because that one's smaller. Okay, number 2 is tricky. Look at how many absolute value signs and how many negative signs I have. Oh my gosh, this is crazy. All right, so I am going to bring down that negative sign right there. Bring down that negative, okay? And then I'm going to think about, okay, how far away is -17 from 0? -17 is 17 spots away from 0. Okay, now I'm going to compare it to my other one, and I'm going to do the exact same thing. Bring down that negative sign, and then I have absolute value of -15. -15 is still 15 spots away from 0. So which one is smaller? Remember, as the negative numbers go down, the further down the left they are, the smaller they are. So even though when 17 is positive, it's bigger than 15, when they're negative, it's the opposite. Okay, this one's gonna be the smaller one. So I'm gonna pick -17 as my answer on that one. We are almost done. We got a few more. Okay. All right, we got to determine if the inequality is true or false. So when you see this on my math lab, you're just going to have an option for true or false. Okay. -18 less than or equal to -2. Okay, let's think about this. So I know I just did a bunch of absolute values. This guy right here is not an absolute value because those are parentheses. They're curved. So this time it's okay to take negative and make it a plus. This is okay because I have the curly ones. So right now I have -18 less than or equal to, the two negatives cancel out, makes it a positive. Is -18 less than or equal to 2? Yes, it is. So I would put true on that one. Number 2, I have absolute value of negative absolute value of 3 greater than absolute value of negative 5. Okay, we got some simplifying to do before we decide if this is true. So this negative is on the outside of absolute value bars, so that means I got to bring it down and it stays. 3 is 3 spots away from 0, so I'm going to put negative 3 greater than absolute value negative 5. Negative 5 is 5 spots away from 0, so I'm going to put a 5 right there. And let's see if that's true. So negative 3 greater than 5. That's a no. So we're going to put false in that one on my math lab. All right, last problem. Okay. Oh man, we got a big word problem and a table with a lot of stuff in it. Okay, so the table shows the percent change in the price index from 1998 to 1999, and it wants to know which category shows the greatest change from 1998 to 1999. Okay, so it wants to know, like, what it wants you to do is it wants you to look at, the first part is it wants you to look at right here, which category shows the greatest change from 1998 to 1999. It's talking about this column right here. Okay, so the biggest change. And so it wants you to look at the biggest change, and the biggest change is going to be this guy right here, this food part. Okay, because look, see how it went, it changed 5.1%. So that's going to be my part A. So biggest change is going to be food. Okay, and I think that's a drop-down menu. So I think you would just pick food from the categories and call it good. Now part B says which has the greater absolute value? The change in private transportation. Okay, so this is the private transportation section right here, and we want to compare the number in 1997 and 98 to this one right here. Now it did say absolute value, so we're thinking distance away from 0. So negative 5.3 is actually 5.3 away from 0. Negative 2.0 is 2.0 away from 0. So that first year, so the 1997 to 1998 actually has the biggest one. Alrighty, so I did peek at your homework, and there is one more thing that I do want to talk about. It technically comes up in a later section, but there's a couple questions on it. I just want you to know what it is. So it asks for what's something called the additive inverse. Okay, additive inverse is just the opposite sign. Okay, so like if I had something like positive 3, okay, then the additive inverse would be the opposite. So, wow, that's not how you spell inverse. Wow. The opposite would be negative 3. Okay. Same thing if I had negative 6, then the additive inverse would be the opposite of negative 6, which is positive 6. Okay. So sorry about that. Sorry that it wasn't in your notes, but now you should be good to go on your homework. Bring any questions to class tomorrow and have a great rest of your day.